Hi everyone. In this video, we are going to see about how to solve the job assignment related problems, which is one of the repeated questions in most of the mining gate examination. If you are watching this video for the first time, kindly subscribe to our channel Suranga Oli so that you will get notified whenever we post videos related to mining. The job assignment related problems are solved using the method called Hungarian method. In order to learn about this method, we are going to solve a question asked in the mining gate examination. By solving this question, we are going to learn how to use the Hungarian method. The question is, the assignment problem requires 4 different jobs to be done on 4 different machines as given in the tabular column. In this question, we have to find what is the minimum cost of the assignment. By simply seeing the problem, we are not able to understand what they have given in the question or what they have asked in the question. In order to learn it easily, we are going to analyze this problem from a mining engineer point of view. Now, let's assume an excavator to be a machine which is abbreviated as M. This excavator machine has to load a particular type of material onto a tipper. That loading operation is considered to be the job of that machine. So that is called job and is abbreviated as J. In relation to the question, let us assume that in our minds, we are having 4 types of excavators, namely M1, M2, M3 and M4, and we have to handle 4 different types of materials into 4 different type of tippers, namely J1, J2, J3 and J4. According to the values given in the tabular column of the question, if the machine 1 does the job of J1, it will cost you rupees 27. If it does the job 2, it will cost you rupees 33. If it does the job 3, it will cost you rupees 30. And if it does the job 4, it will cost you rupees 38. If the machine 2 does the job of J1, it will cost you rupees 35. If it does the job of J2, it will cost you rupees 37. If it does the job of J3, it will cost you only rupees 26. Or if it does the job of J4, it will cost you rupees 29. When the machine 3 does the job of J1, it will cost you rupees 36. If it does the job of J2, it will cost you rupees 36. If it does the job of J3, it will cost you only 28. Or if it does the job of J4, it will cost you rupees 35. Finally, if the machine 4 does the job of J1, it will cost you rupees 30. If it does the job of J2, it will cost you 35 rupees. If it does the job of J3, it will cost you only 24 rupees. If it does the job of J4, it will cost you rupees 33. This is what they have asked in the question. What is the minimum cost of assignment? Before solving the problem, let us randomly assign a particular machine, particular job, and let us see what is the total cost of assignment when we randomly does it. For example, let us assign M1 to J1. The cost is rupees 27. So let us put 27 first. And we are allocating M2 machine to job 2. So our cost is 37 here. And for M3, we are assigning J3. So that cost is rupees 28. And we are assigning M4 machine to job 4 and its cost is 33. When we randomly assign the machine to a job, we are getting the total cost of this assignment as rupees 125. In this problem, we are going to find what will be the minimum cost of the assignment using the Hungarian method. In this Hungarian method, we have to follow 3 easy steps. Step 1, row reduction. Step 2, column reduction. And step 3 is optimization. First, let us see the step 1, row reduction. In this step, we have to subtract the smallest element of each row from all the element of the row. First, let us take the row 1. When you see the values in the row 1, the value 27 is the lowest. So, we have to subtract all the values of the row 1 with 27. On subtracting, we are getting values as 0, 8, 9 and 3. Now let us take the second row. When you see the values of the second row, the value 33 is the lowest. So we have to subtract the 33 with the other elements of that row. On subtracting, we are getting values in row 2 as 0, 4, 3 and 2. Now let us take the row number 3. Among the values of the rows 3, the value 24 is the lowest value. So we have to subtract the other values by 24. On subtracting, we are getting values as 6, 2, 4 and 0. Now let us take the row number 4. When you see the values of the row number 4, the value 29 is the lowest. So we have to subtract the other row values of the row by 29. On subtracting, we are getting values as 9, 0, 6 and 4. By doing this, now we have completed the step 1 called row reduction. Step number 2, column reduction. Column reduction is also similar to that of row reduction. In this also, we have to see the lowest value in the given column, and that lowest value should be subtracted by the remaining values in that given column. In this, you can see the column number 1, 2 and 4 has the lowest value as 0. So subtracting 0 by remaining values, we are going to get the same value. But in column number 3, we are having the lowest value as 3. So we have to subtract the remaining values of the column by number 3. On subtracting, we are getting the values as 6, 0, 1 and 3. Step 3, optimization. We have to do optimization row wise, and if there is any need, we have to do optimization for column wise also. For doing optimization in row wise, we have to scan the each and every row and we have to look for the value 0 in that row. When we scan the row 1, we are having 0 at the intersection of M1 and J1, and we mark that value 0. Since it is having only one 0 element, the job 1 is assigned to M1, and according to the problem, if one machine is assigned to the one job, it cannot be assigned to the other. So we are now striking the column M1. Now let us scan the row 2. The M1 is not option for job 2 because it's already assigned. Analyzing the remaining elements, we are having 0 at the intersection of job 2 and M3, and we are marking that, and the machine 3 is allotted to job 2. in row 3, we are having 0 element at the intersection of J3 and M4. So the machine 4 is allotted to job 3. At the row 4, we are having 0 at the intersection of job 4 and machine 2. So the job 4 is assigned to machine 2. Since we are getting solution from row-wise optimization itself, there is no need for column-wise optimization. But there may be sums coming related to column-wise optimization also. If you need that column-wise optimization technique also, please comment below. I will put a video related to that example. From the optimization table, we come to the conclusion that in order to get the minimum cost, the machine 1 should be allotted to job 1. And according to the table, its price is rupees 27. And the machine 2 should be allotted to job 4 and its price is rupees 29. And machine 3 should be allotted to job 2 and its price is rupees 36. And the machine 4 should be allotted to job 3 and its price is rupees 24. According to the question, they have asked what is the minimum cost of assignment is. And the minimum cost of assignment is the summation of all the machines and their job we are getting as rupees 116. Instead of analyzing this problem in the normal way, we have analyzed it in the form of mining engineer. Hope you are able to understand this problem easily. Go through the previous year's GATE question papers and try to solve many assignment problems so that it will be easier for you to solve in the examination. Hope this video was very useful to you. Subscribe to our channel for more videos and press the like button if you like the video.